Right, we'll see. What are we live? We'll see. I think we're live. Yes, looks like we're good. So firstly, hello to all of the people that I've just been chatting to. It's been very nice having sort of a pre-show chat. That's good. And hello to all of the people that I missed in the last 5 minutes. Thank you very much for dropping by. Somebody shout out, make sure you can hear me. Yes, you can. Good, we're live. Good. Excellent. Right, so I'm going to be sort of casting an eye over the YouTube chat as well as getting on with the video. And the reason I'm doing this live is I have been very, very busy in real life. For those that follow the channel, you'll have noticed maybe way back when, 100k subscriber special, I said there'll be a period of this year where I'm not going to have any time at all. And I'm right in the middle of it with a real life project, very exciting project. I build robots for a living and we've got a big customer and it's just taking up all of my time. So I thought what we'll do is a simple video on this block sliding puzzle, and I'll do it live. So we're going to have lots of bugs and errors and all sorts of things going wrong. So periodically, I'm just going to have a glance at the chat up here just to make sure I'm not missing anything. But it looks like we're all good and everything's set up, and hopefully the volume is fine and we can just start. So I'm going to be using the Pixel Game Engine as normal. Now I know some of you during live specials like to follow along. And to start with, all I do is I've created a blank C++ file, and in the Pixel Game Engine header file you'll see some text of a blank skeleton program, and I recommend that you copy and paste all of that into a blank C++ file and strip out the bits we don't need. There will be a section during this where there's going to be a little bit of a Q&A, I think, so I'll try and answer some of the questions as we go, but I don't want this stream to go on for hours and hours and hours and hours. So I'm going to just push on with it. Right, so the type of game that we're thinking about here are along the lines of Sokoban, right? The thumbnail should have given that away. The idea is you control a player and the player can push blocks around and you have to get blocks over goals, and some of the blocks have certain restrictions on what direction they can move. There's a whole bunch of different mechanics. And what I thought would be interesting was to create a video on how simply we can implement these mechanics and how we can build a framework upon which we can extend and add new and interesting stuff. So we won't actually really get around to designing any puzzles today, just really the framework. Right. So where should we get started? And this is the beauty of doing things live. Full disclosure, I have got a little bit of a prototype. Obviously you saw the thumbnail, that wasn't just a mock-up, but I will be sort of coding it all as we go along. And I think what we'll do is we'll start with something that renders a basic level. And I'm going to keep this very, very simple indeed. So you'll have to excuse now the real typing and the typos as we go along. So I'm going to represent a basic level as a string. That's how I usually like to do things in prototype form. And I've already set my console game engine screen to be low resolution 256 by 240. Now, we're working with blocks, so how many blocks can we sensibly fit into that resolution? And it works out that 16 by 16 pixels is a nice size for a block, and we can therefore fit 16 by 15 blocks entirely on that resolution. So I want to create some sort of basic level template, and I'm going to represent it as a string. And I'm going to use the symbols hash. Now, if you've watched the first-person shooter videos, you'll see this before. I have to count these out. 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, that's good. And I'm going to want 15 of these. Now, you'll notice I'm not putting a comma at the end of things. Hang on, I've lost count already. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's my full level. The C++ compiler will automatically concatenate all of those into a single string. So I'm going to use the hash symbol or pound symbol or whatever it is from wherever you're from to represent solid blocks. So we'll start there, and I'm going to represent dots to show, well, there's no block there, so nothing at all. And we'll notice later on that there are some limitations with this approach, but just to keep the video simple, I'm going to be using characters to define the levels. And I'm sure it's not a big leap for you guys to see, well, hang on, we could have different strings representing different levels later on. So let's just get some basic framework to start some rendering up there. I'm going to need a few other bits and pieces of information. For example, how big is the level? Because I've got this string, but it doesn't tell me anything about the dimensions of it. So I'll create a vector. Oh, hang on, I'm programming in the wrong language here. VF2D, that's the floating point type vector. And I'm going to call that V level size. And I'll just initialize that to 16 by 15. Yes, good, excellent. Have a quick glance at the chat. That's where I have to go quiet whilst I'm reading it, because the chat moves a lot quicker than I used to. No, I'm not going to be using command line graphics for this one. I'm going to be using Pixel Game Engine. Now, we know that each block or tile or whatever you want to call it in my level is going to be 16 by 16. So I'm going to just cache that here. It's useful to have it as, well, just a convenience variable. It also means we can change the size of things later on. So as I mentioned at the start, this is really going to be a video about creating some customizable framework for us to later on develop more and more things into. So we've got level size and we've got the block size. So let's go down to on user create, and just before that I'm going to create a function called load level. We might have different levels and things later on. We might want to choose them. Do you know what? I'll give that a parameter I. You know, I'm not going to call it I. I'll call it n because I use I as indices and things. And the whole purpose of load level is going to be to turn our string into something that represents the level, and we'll get back to that in a little while. So I think next what we'll add is something to render the level, maybe? Or should we start thinking about the blocks? Let's think about blocks. Let's create a basic block structure. Struct block. What is it to be a block in this level? Well, I'm going to try and use object-oriented programming for this. When I did the shoot 'em up, I used very procedural programming for that, and we gave the different entities in the game different behaviors and different rendering styles by sort of using function pointers. It was a very strange way of doing it, but it worked very well. We just wanted a small minor change. In this instance, I'm going to use sort of polymorphism, very, very simple stuff, in order to construct the world. And we'll look at how we can move the blocks around and the mechanics sort of next. But for now, let's just get it rendering something very simple. And my block is going to be a base class for a block. Those that are following along, hopefully you don't miss too much. But I will put the source code up at the end of the video, as I always do. And it will be the source code warts and all in this case. Right, I'm going to give our block a basic constructor. Now, a struct and a class just saves me having to type out public all the time. I'm not too interested in the security of object-oriented programming for this. But I am interested in allowing the blocks to be able to draw themselves. So I'm going to put in a base class called drawSelf. And we'll flesh this out a little bit as we start developing the application. But whenever you have an object in Pixel Game Engine or whatever platform you're using that's drawing itself, somehow it has to have access to the drawing tools. So I'm going to allow it to pass in a pointer to the Pixel Game Engine. You also get to see me sort of picking my nose and all sorts of things when I'm doing these things live. The block is going to exist somewhere in space. Now, I don't want to create an array of blocks as such where they all know their own location. This block is more a description of what does the block look like and what is its behavior. So I need to pass in some information to say where this block actually is in the world. Where's it going to be drawn on the screen? So I'm going to pass in a two-dimensional vector for this, pos, and I'm also going to pass in the same again for the size. Now these are integer vector types because everything's going to be nice round even pixel numbers. There we go. drawSelf. Oh, we need a return type on that, don't we? Put a void there. Very good. Let's have a look at the quick chat. Good, not seeing anything going terribly wrong. Excellent. Where's the caffeine? Unfortunately, no, there's no caffeine here today. Right. So my load level is going to construct blocks. So I need to store these blocks in something, and I'm just going to store them in a vector. Standard, not a standard OLC vector, just a standard vector in this instance. But I want to use polymorphism. So if I'm going to store all of these blocks in a vector, I can't just store them as blocks. I need to store them as pointers. And I'm going to do something unusual. Oh, thank you very much, Tom. Have you ever used Pascal or Delphi? What do you think the place for other languages is in a space dominated by Python and C? I have used both Pascal and Delphi. In fact, when I was a teenager, that was what they were teaching at the time, was Pascal at least, and then I moved on to Delphi a little bit later on. What do you think the place for other languages is in a space dominated by Python and C? It's very tricky. I think there's a lot of languages which are not getting as much support now, particularly things like Pascal and Delphi. Are they still that relevant? Well, the purists will say yes, and some of the computer scientists will say yes. But I think, I mean, I'm biased. I like C++ because I can use it without having to think about it too much. It's very second nature to me. So to suddenly say, well, I'd prefer to write this application in Pascal, it's just not really a decision I would ever sensibly make. I've also noticed now that you're right, so things like Python and Lua and C++ and now things like Rust and Go are gaining great popularity. I'm not too familiar with Rust or Go, but hey. So does Pascal and Delphi have a place in the world today? Undecided. I think as enthusiasts, yes they do, but as production level development packages, probably not, simply because there's little guarantee that they're going to be around in 10 years' time. And if you're working for a company who's producing software and you have to support it for its lifetime, is it going to be around? Is the talent pool going to be there? Don't know. This is live, yes. Right, so what we're going to do is store, we're going to use some smart pointers. Now that's a rare thing for this channel, but it does make life a little bit easier for us later on. So we're going to use unique pointers, and we're going to use unique pointers to block the type we've got. Now, all of this will be a little bit cryptic to start with, but we have to just get going somewhere, have to have some sort of basic framework. And once we start rendering the framework, you'll start to see, yeah, that makes complete sense. And so I'm just asking you to run with me a little bit on this. And I'm just going to consult my notes. What did I call this vector? Because I'll start typing it out and then I'll have to start changing absolutely everything. And so I do need a bit of a backup plan. Oh, hang on. Whoa, whoa, whoa. Getting all sorts of pings and things going on. Suik, hello. Thank you very much. Hello, yes. Suik, that's an interesting name. And Sleeping Bear, hello, 50. Wow, that's a big donation. It's good to see you, Sleeping Bear. I know you do pop up on the server periodically, and we just always seem to be like, we have a phrase called ships in the night. We always seem to miss each other when we're chatting. Yes, I hope your studies are going well anyway, and I hope things are working out for you. And hurry up and finish that paper, because it's a really interesting thing, and I want to show it in a video. Right, it's a bit of a mess when you have a vector of smart pointers. Yes, it can be a bit of a mess. That's the only downside with the standard library and smart pointers and things like that, is it can get a bit wordy. Regardless, let's press on. I'm going to call that vlevel. Now I know people go, oh, he's using Hungarian notation. Yes, I use just get used to it. I prefix things with the types. A little mental hint for me. I quite like it. Now, where were we? So in onUserCreate, the first thing I'm going to do is just call my load level function, one way or another. Suik, thanks for all the videos. They've helped a lot, although you're struggling with the 3D stuff. Oh, well, yeah, the 3D stuff, it's not that simple. It is complicated. You need to understand a little bit of the mathematics. Now, I've tried to approach it in such a way that you don't have to have seen all of the maths before, but certainly if you've not covered it in school yet, or you've never had any formal training in trigonometry and geometry, they can be quite tricky. I started out because I was dabbling with 3D graphics well before I started playing with trigonometry and things in anger at school. Certainly matrices, never even looked at those. And I just used to take the parts as black boxes and just simply say, well, I know that whatever that thing is there, it rotates my geometry. And I kind of understood how it did it. And certainly by using them as black box components, it helped me understand them. And I think later on, when I did go to learn these things at maths in school and university, I found them much simpler, simply because I'd programmed them. So it kind of helped me learn these things to run with. But yes, 3D stuff, if it's new to you, it is a bit tricky. And some people spend their entire lives working on nothing but 3D programming. I think there's something to be said for good old 2D programming, particularly when it comes to some of the geometry, because a lot of the stuff that you can do in 2D you can easily extend into 3D. What's the clever thing about using a unique pointer? I'm just picking a question at random here. What's the clever thing about using a unique pointer? The clever thing about using this unique pointer is when I clear the level, it will free the memory up. But we'll also see, why am I using a pointer in the first place? Why am I not just storing the blocks? And that's because I'm going to exploit polymorphism, and I need things to be pointers in order to exploit polymorphism. So yes, somebody asked me this question the other day. Experto, did you work on War of the Monsters? No, I'm sorry, it wasn't me. Right, I'm going to push on for 5 minutes and answer some questions a little later on. If I do miss your questions, I've sort of scheduled in this later on. We're going to be drawing some of the blocks. That's probably a good time to do a bit of a Q&A. Right, so I completely lost where I'm up to. Load level, what are we going to do? So we need to load our string and convert these into our block type. So let's do that. We'll have two nested for loops. Int y. I got shouted at once for doing x and then y. You should actually do y and then x. It can be a little bit more cache efficient, though, you know, hey, so what? A few extra clock cycles between friends, what's the problem? And we created this vector size thing before to give us the dimensions of our array. So I'm just going to grab the height of it out of there. Respect for your work from Australia. I'm looking forward to teaching others in code myself in the future. Very good. I think it's important that once you have got a little bit of programming knowledge, pass it on, right? Lots of people don't have it, and it's one of those things that's really useful to do. It's easy enough to pick up to a usable degree. Okay, it's difficult to master. I won't argue with that, but you know, getting it working for you. When you're starting out programming, one of the first things you'll realise is, hang on, everything seems like hard work. But after a while, it sort of clicks, and you go, well, hang on, this is actually making my life much easier. And you start developing tools that help you. And that's definitely sort of, once you've hit that point, you know it's for you. It's going to be what you need to do for the rest of your life. Right, so yes, so far we've created a nested for loop. I keep getting distracted, I should stop looking. And now, one of the nice things about having things in a string array like this is we can easily access that array. So I'm just going to call switch, and to that I'm going to take our string variable, and we can pass in a coordinate. Now, we all know this, and if everybody's not shouting this out at once, we know that it's going to be y, or lowercase y, times the width of our level, plus x. So we're going to convert those 2D coordinates into 1D. Why y before x? Well, traditionally, if you're storing things in an array, usually your x's are closer to each other in the array contiguously rather than the y's. So basically, as I'm iterating through this array now, the change from one array element to the next is minimal. It's a single x, it's a single 1 each time. So I'm going to get better cache performance iterating through my array that way. But don't worry about it. I mean, that's the reason why, but it's not that important. Unless you're doing really critical sort of image processing code or really hammering arrays a lot. Because if I did it x and then y, the inner loop being y means I've got a huge jump potentially between elements, and they may not be in the cache. So that's all it's really about. Right, so I'm going to switch based on the character I'm reading. So I've converted my 2D into 1D, and that will give me a location somewhere in here. And now I can put in some case statements. So if we are a solid block, we're going to do something. And if we are a full stop, do you know, I'm not even going to bother with the full stop because I'm just going to leave that as default. Stops playing Noita to watch David get distracted. Yes. Is it any good, that game? I've seen it, and it looks reasonably interesting, but I don't know. I don't know if it's for me or not. Right, so we know we're going to have two types of block. We've got one which is solid and something that doesn't exist at all. But right now, all we've got is this basic prototype of a block. So I'm going to copy all of that, and I'm going to duplicate it down here and call this one as block solid. So these are going to be blocks that cannot move. I don't even need the constructor for this. And just, you know, we'll do it properly. We'll get rid of the virtual and we'll put an override at the end. It keeps the pedants happy. He says, optimistically. Why have we got a thing? Override does not override a base class member. Yes, it does. Oh, no, it doesn't. Because we need to inherit from our basic block. There we go. Come on, fingers, wake up. There we go. Told you, I'm terrible at typing. This is the advantage of doing a video, is I get to edit all this stuff out. Now, if it's going to be a solid block, we're just going to draw it as a filled-in rectangle. So I'll take the pointer that we've passed in through the Pixel Game Engine, and I'm going to call fillRect, and I'm going to give it the position times the size. So the position is going to be in sort of tile space. So up here is 0, 0, and down here is 16 by 15. But when we're drawing it to the screen, we need to know the size of the blocks, and that's why the position is multiplied by the size. The size of the block is, of course, just the size, and I'm going to colour those in blue. There we go. So all we've done now is created a subtype called block solid, and it just draws itself blue, whereas a regular block doesn't do anything at all. So now I can push into my vector at the correct location, well, in place black, and this is where things are going to get a little bit modern now with lots of wordy stuff. We're going to make the unique pointer, and we'll call this one block solid. So this will handle the polymorphism for us. We're basically now creating a pointer, so that's handled just fine. And there is no constructor to pass in, so it's just, that's it. That's all we need to do. Now, that's when we encounter the hash symbol. We're going to put a solid block in. But what are we going to do for all of the other blocks? In this case, they're all period symbols. We're just not going to put anything at all. But I don't want to do that, because right now my vector will consist of only the things that are there. And I'm going to exploit the fact that we can have, hit my microphone, going to exploit the fact that we can have empty blocks. And for an empty block, I'm not going to create a special type or anything, I'm just going to use null pointer. So in the situation that we get a block that we don't understand, or in this case the period symbol, I'm simply going to push null pointer to my vector. Right. I'm just going to have a mouthful of go. I suppose there's some caffeine in that. I know that was a question, wasn't it? Right, so now we want to draw our array. And we're almost halfway done with the actual framework here, because you'll see pushing the blocks around isn't actually very complicated. Have a quick look at the chat here. Yes, I think on the whole, console game engine is not something I use very much anymore. It's unfortunately Windows kept doing updates and things to the terminal. I guess they wanted to push the new PowerShell and the new terminal products out there. So the original command prompt is no longer as flexible as it once was, and it now suffers from a bit of a performance hit. Things still do work, but use the Pixel Game Engine instead. Right, so we're going to draw stuff. That's what we're going to do first. So the first thing I'm going to do is clear the screen to black. And that will mean we're starting from a blank canvas each time. And now I want to iterate through my vector. So this vector will now contain the same number of elements as our map contains. And they'll be in the same place if we index them in the same way. So there's a correlation between that and the types of blocks that we put there. So I'm going to create a little variable here called tile. Oh dear. vi2d in this case. And we'll call that tile. And this is going to be what we're using to count through the tiles as we're drawing them. So I'll initialize that to 0, 0. No real need to initialize it there. It's just well, force of habit, I guess, now. So, tell you what, I will call that vTilePos, so it's very explicit that we know that that represents the tile's position in tile space. TilePos.x, and we're going to begin at 0. Oh, we've just had a debate about this, haven't we? Let's do it in y first. Let's be consistent. TilePos.y is less than vLevelSize.y. So we're just literally going to iterate through absolutely everything. TilePos.y, there we go. And inside there we need another, but for x. X, 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 and x. Excellent. Now, the reason I've not just used x and y in this case is a lot of the drawing functions and things can take in this integer 2D vector type, so it's just convenient. So now I've got an index to a particular tile in my array, I want to be able to sort of access it frequently. I'm going to create a small lambda function to help me out here, because I'm going to be frequently turning these x and y positions into 1D positions for my vector indices. Kind of like what we did here, but I'm going to wrap it up in a nice little lambda function. I'll call that ID. So C++ lambda functions, well, they're one of those things that are a bit curious and unique to C++. Other languages do have them. So if you're following along in a different language, just create a normal function that returns a single integer in this case. I'm going to call it ID. And I'm going to just capture everything, which I know you shouldn't do, and I'm going to pass into that. Let me just consult my notes before I get carried away here doing something incorrect. All right, yes. I'm going to pass into that my vi2d, just a reference to it, pos. And all this lambda function is going to do is do what we said before, this y times the width plus the x. So pos.y, well, I need to put a return in, don't I? That always helps. Pos.y times everything's going to be relative to level size .x plus pos.x, and that's our little lambda function. So that's just a utility function. It's just going to save me having to type this out over and over and over again. Just convenient. Now I want to get the type of the tile from our vector. I'm going to use auto to do this, because I could be getting back all sorts of different things. Fundamentally, it's going to be a unique pointer to block, but I want to be able to treat it as different types. So what did I call this variable? I think I just called this variable b. I did call it b. There we go. That was convenient, wasn't it? B for block. So now I can access my vector of blocks. I can call my little ID function, and I can pass in my TilePos vector. And that's going to give me the pointer to the block at that particular location. So all of this so far has just been about making the syntax easy to follow. Like I say, if you've not got C++, you can implement this in many ways in, well, it's just a function that takes in an x and a y and returns an index. Very simple stuff. Now, it could be that b is null pointer, so that's something that we want to check for, because null pointer means there's no block here, don't do anything. So I'm just having a quick glance at the chats here. What would you move out of this CPP file into a header file? Yeah, so I tend to do everything in one file because it's convenient for the video rather than me flicking around. But ultimately you could create your, well, anything that's got a body doesn't need to be in the header file. That's as simple as that. Now, the beauty of this approach here is now I can just simply call the drawSelf function. And all I need to pass in is a pointer to the Pixel Game Engine, the tile position, and the tile size. Do I not have a tile size? What did I call it? What did I call it? Something else. I called it block size, of course. Why not? Is it block size? Should be block pos then, I guess, shouldn't it? But hey ho. Block size. Right, I'm just going to zoom out a tad so we can just see a little bit more code. If it gets a bit too small on the screen, I apologise, do shout out. So here we've got our rendering framework, and so far that is all we're going to need, because the blocks are going to be capable of drawing themselves. Let's have a quick test compile and see if it's got lots of syntax errors and things that we need to work out. And let's run it. Oh, it's not looking very healthy. I think we've got an error somewhere. Ah! Well, that's not going to help, is it? We've got no increment on the end of our loops there. Have I forgotten those elsewhere? There we go. Let's try that. Ta-da! So, yes, we've drawn a black rectangle, it would seem. No, what we've done here is draw for the individual tiles. We've now got them on the screen. Now, if we want to prove that that's the case, let's just go and bang in a couple more things here, just some simple obstacles. If we run it now. Excellent, so we've got our square tiles and we've got a convenient way of rendering them. So let's take the example a little bit further. We're going to need a starting position. NPC unit. Keep up the great work, your videos are useful, take care of yourself. Thank you very much, Em. That's very kind of you. Yes, and I think that's a good message to absolutely everybody during these really frustrating times. Everybody says unprecedented and doom and gloom. It's just more frustrating than anything else. And I think it's important that people do take the warnings reasonably seriously. I'm sorry if that doesn't align with your political beliefs, but it's just common sense that we shouldn't all be spitting and gobbing on each other in the streets. So do take responsibility for your surroundings. That's my only political message I'm ever going to say on this channel, but I feel I'm getting tired of the whole thing and I want it to go away as quickly as possible. Right, so what we're going to do now is create another block type, and we'll have this one as the player, and wherever the player starts is going to be the letter P. So I'll just copy and paste the implementation of our block solid, and I'll call it block player. And the player I'm going to draw as a white rectangle, and here we'll start to see the real powerful nature of polymorphic programming, why it's useful, why it's one of those things that yes, people will moan about, but it's worth learning nonetheless. So we've got our block player. If I want to add a new type, I know it's wherever the letter P exists. Let's just go and change this to block player, and I don't need to change anything else, don't need to tell it that anything else exists. We've got a new thing in our game that's separate and controllable, but we don't need to change our rendering framework. So that's quite a nice thing to have. Yes, notice the lack of increments. Well, thank you everybody for shouting that one out. God, I miss editing. Now, I think it's time to start talking about how we're going to move the blocks around. We can see that we can easily have different types. In fact, why not? Let's just add another one just to prove the point. We'll have another simple block. So simple block is going to be a block that can be moved in any direction. And we'll talk about the movement just after this, but let's colour it in. Simple blocks are going to be red for now. We're starting off with very simple graphics. Don't start off by drawing the graphics first. Just start off with simple placeholders. And so we'll have simple blocks. We will have plus as the symbol, which means they can be moved in any direction. So I'm just going to scatter a few around the world here, and later on when we start moving them around we might want to see how they behave in different orientations and that sort of thing. So simple pluses, and we will add into our level loader the plus symbol and call that block simple. Just double check that that's worked. Very nice. Okay, we will update these graphics towards the end. Yes, I don't do live very often on YouTube, but I do Twitch occasionally, and I'm live fairly frequently on Discord. And if you've not joined the Discord server, I recommend that you do come and have a chat with us on the Discord server. And I've got another actual thing I wanted to mention. The OLC Code Jam 2020 is going to start as a bit of a time off, but in 1 month's time, that's when it's going to start. So if you're interested, check it out. It's itch.io/jam/OLC Code Jam 2020. In fact, you know what? I will paste a link in the chat there. There we go. Right, we want to talk about how we're going to shuffle the blocks about. So let me just pull up OneNote, because we like OneNote on the channel. Here's my 2D array, and I'm going to draw into this some simple blocks. Simple blocks we decided were going to be red. So let's say I've got a block here and a block here. And I'm also going to have my player. Now, do you know what? I'll do the player in black. The reason being is I might want to use blue for a solid wall. Simple blocks are capable of moving in all directions. So I'll use the plus symbol to indicate what directions they can move in. And the idea is that the player is going to exert a force in a particular direction. And don't worry, we're not going to get all physics and collision detection in this video. It's really not necessary. But they're going to exert a force in that direction. And what we're going to do is propagate that force along. So the first thing we'll check in that direction, we'll see. Well, tell you what, let's just back up a little bit there. Oh, I've got to delete this now without deleting the whole background. That's the downside of OneNote. We know we're going to start where the player is. And so the first thing I'm going to interrogate is, can the player move? Well, players can always move. We're going to set that up as a rule. Can it move in that direction? Well, it needs to find out. So it's then going to go and look at its neighbour in the direction it's pushing and say, can you move? Are you allowed to move? And this block will go, well, yes, I can move in any direction, but I just need to double check with my neighbour. And so it does that. Can you move? And this one goes, well, yes, I can move. Let me double check with my neighbour. Oh, hang on, I've not got a neighbour. I'm now in null pointer land. It's a very boring place. And when we propagate like this and we reach this null pointer, we know that there is empty space, so it is possible in that one cycle to push all of these blocks along once. Let's just leave null pointer land for the moment. What if there wasn't? What if there was a solid block? This solid block will have responded, well, hang on, I can't move anywhere. At which point, this red block, simple block in the middle, that can't move anywhere. The first red block can't move anywhere, and the block representing the player can't move anywhere. So if we end up in a situation where the blocks can't move and we've not hit a null pointer for that cell, well then nothing else can move. But let's now go back into the very exciting null pointer land. I knew that would happen. This is the downside to OneNote and deleting things. It is a pain. Once we've realised there is empty space here, we can then systematically work backwards and swap the empty space with the blocks. So we can swap you with this block, which will of course move this red block over to this null pointer. I can't draw that out very easily without deleting all of the screen. And then we can swap again. And we'll keep swapping until we get back to the starting position. And that will have the effect of moving all of the blocks along once. So in this instance, the player can push multiple blocks along, providing that the blocks allow them to be pushed and there is space to push them into. This is where we're differing from Sokoban, where I think you can only push one thing at a time, but we could implement a restriction to allow us to just move one block at a time, but I'm not going to do that. I think it's more interesting to have sort of collections of blocks pushing around, because you can then start to think of more interesting puzzle dynamics. But where do we factor in how can a block move? How is it going to tell us that it can be pushed in a particular direction? So I think we need to implement that next. Let's have a quick glance at the chat. What about pulling blocks? Well, we can talk about pulling blocks a little later on. But for right now, this is a simple video. It's a simple algorithm because I'm doing it live. I'm going to do pushing blocks. Excuse me. And I'm going to need some directions. Now you're not allowed to use hash define anymore, so you need to use const expression. And you need to spell it right as well. There we go. Let me just zoom in a little bit more so we can see. Int, and I'm going to have the first one as north. I'm going to give that the value 0. And we're going to go round in clockwise order, so east, south, west. Now it's important that you get the order correct, because there's a trick you can do with the order, and we'll be seeing that trick in a moment. Now on my base blocks, just zoom out just a tad, I need to have a function that tells me, is this block pushable from a particular direction? So let's put that in as a base function. And it's going to return a bool. Why can't you use hash define? No, so that was me being a little facetious. You'll get basically all of the C++ pedants coming out of the woodwork and shouting at you now because, well, it's not the nice way to do things. Hash define is basically cut and paste. Doing things with const expressions allows some degree of control over what's going on from the compiler. You could use an enum class or something else, but the downside with enum classes, I find, is you're always casting between them because there's a lot of value to being able to use an enum both in name and numeric position within the enum. However, that's a debate for a different time. So I'm going to add a function here called push. Now this isn't going to move the block. We can see already the block doesn't have any knowledge of where it is in space. But what it's going to tell us is what is its behavior when we want to push it. And so we need to provide it with what direction are you being pushed from. And for our base block, we're going to assume that all blocks can be pushed in all directions. Note that it's not checking its neighbours. It doesn't know anything. All it knows is that if I am pushed, I can be moved. Very good. Conversely, for our solid blocks, we know that they can't be moved. They can't be moved in any circumstance. It doesn't matter what direction, so I'm just going to set that to false. The player block so far can be moved because the player we want to be able to walk around the level. And what we'll see as we add more blocks, such as blocks that can only move horizontally and only move vertically, then we'll need to change the calculation performed in this push function to give us those different behaviors. But we'll get there in a bit. And we've also got our simple block, haven't we? A simple block is very similar to player, except it renders red. Yes. There we go. So simple block is one that can be pushed in all directions. Why both snake and camel case? Why not? Where am I up to? We're up to movement. Okay, good, good, good. Sorry, I'm catching up with some of the chats. Oh, it's from Aman. Yes, Aman, yes. Thank you for posting your video. Right, we need to handle some user input. That's how we're going to start this algorithm. And even though what we've just looked like seems like a brilliant candidate for recursion, I'm not going to use recursion either. It's so simple we don't need to. There's really literally no code to this, but you'll see that the end result is very pleasing to push things around. So what I'm going to check for is the W, A, S and D keys being pressed. And in the Pixel game engine, you just simply choose the key, and if it's being pressed, that gives you a true on the frame that the key has been pressed on. So that, it won't repeat anymore. You just sort of get that one hit. And I'm going to need that for all four directions. W, S, A, and D. Of course, if your keyboard layout isn't W, A, S, and D, you could use the arrow keys just as happily. And what I want to convert is this key press into the action of pushing. So I'm going to create a Boolean variable, spell it right, pushing, which by default is false. We're not pushing anything unless we're pressing one of these keys. But I also need to store the direction. And we'll call that push. And I'll just store that as 0 for now, but we're going to set that to one of our const expressions in the event of pushing being true. So let's just see what I mean by that. So if we're pressing the W key, then the direction we're pushing is northwards. So we can use that constant we created earlier. And I'll set the be pushing variable to true, and this will be true for just this one frame. Very similar for south. here we've got A, which is pushed towards the west, and here we're going to have D, pushed towards the east. Hi Brian, and Fisok, hello. Sorry if I've missed loads and loads of chat, I do apologise, but I do want to get through it, and there will be a little room for some chat later on. We got off to a bit of a slow start, so I'm just trying to catch up. Right, so now we've established that we're pushing and we know which direction we're going to be pushing in. So what do we do about it? Well, first thing, let's be responsive to if we're pushing. Because if we're not, then we don't want to do anything at all. So I just go back quickly to the OneNote. One of the things that we need to know is where do we start doing this search? So I'm going to have a player coordinate vector value pair x and y to tell me where the player exists in the world, and from there we will then, in the direction of the push, start interrogating the neighbour cells. So let's throw in a variable up here. It's an OLC VF2D type. We'll call that vPlayer. Now, we need to set that to something, and we know that we specify where the player is going to be in the level because we've got a B for the character player. So when we load that particular block, we'll also set the position of the player. Which is simple enough. Right, so I'm not going to move the player around so much, but what I'm going to do is maintain a cursor as we jump across the blocks, because I don't want to sort of lose where the player is positioning. So if we are pushing, the first thing I'm going to do is create this cursor location. I tell you something, I've just called the player a VF2D, haven't I? My brain's running slower than my mouth. Where did I put that? Block, 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 block. Should be a VI2D. Everything's in integer space, keeping everything very simple. There we go. So you don't get all of this scrolling when I'm doing the normal videos. That's the. See, it would be easy to get disoriented. So we'll call this cursor vBlock. That's going. I'm going to set that to vPlayer. So that's going to be the first location that we're going to start looking for things. And we need to sort of scroll across these blocks, so I'm going to have to sit in a loop checking blocks in a particular direction. And I want to stay in that loop until I hit this null pointer scenario, which means there's some empty space at the end and therefore we can allow the push to occur. Or I want to abort going through the loop because I can't push anything any further. The movement is not allowed. So I'll create some flags to tell me if we're allowed to do the push. I'll default that to false for now, because that's what we're testing for in this loop. And I'm going to sit in a loop until my testing scenario comes to some form of stop. And we'll see when I start typing that out what that means. But for now, we do want to sit in a loop which sits based on bTest. Yeah. So while bTest is true, we're going to check to see if a block can be moved. Well, firstly, we need to check, does the block even exist? Now, I created this little lambda function down here. Do you know what? I'm going to move that up here because I'm going to reuse it a little bit. There we go. So it's now defined so I can use it within this testing loop. So the first thing I will check for is, firstly, is the block we're testing, is it null pointer? Because if it's null pointer, there's nothing to test. We can't actually interact with it. So I want to be dead safe there. So vLevel, ID, vBlock. Now, if that is not, do you know what? I'm going to be really explicit here so it's clear in our minds what's going on here. So we're testing that there is actually a block in that location. You don't need the not equals null pointer bit, but it's just, it sort of reminds you that it's there. That's what you're testing for. And now the push functions that we've just added to our block types, we're going to check those to see, can you be pushed from that direction? So let's call that function for the block. So if vLevel, we'll type that out again, vLevel ID vBlock, push. Now, what direction do we choose? We've got our direction of push, but the block, rather confusingly, is sensitive to which direction are we being pushed from. It wants the opposite direction. So if we're pushing something in the northern direction, the block is being pushed from the south. So we want to convert that north to a south. Well, one of the convenient ways of doing that is because we've stored these as 0, 1, 2 and 3 in clockwise order. You can see that north and south are 2 apart and east and west are 2 apart. So opposites are always going to be 2 apart. So we can take our direction and add 2 to it, mod 4, so we wrap around because it's a compass, and that will give us the opposite direction. So let's just do all of that. We want to our direction of push plus 2. Ooh, got to start Sir push. Yeah, that sounds pretty cool, doesn't it? Der push mod 4. There we go. And so that's now flipped our direction for us. A nice little convenient mathematical trick there. I'm going to make sure I've got the right number of brackets going on here. Yeah, that looks legit. Okay. If our block allows pushing from that direction that we're pushing in, block allows to be pushed. If that block allows us to push in that direction, so I've got to try and verbalize this, then we want to move our cursor along in that direction. So switch to push, and we've got to go through all 4 of them. There's no real way around this. So if we're going in the northern direction, north is up the screen, so our Y value gets less. This is our cursor's location for the next block that we're going to test. If we're pushing in a southerly direction, then we want to increase our Y value, and we've got something very similar for east and west too. So if we're going in the X, if it's east, we're increasing, that's going towards the right on the screen, and for the west, we're decreasing. So this is moving our cursor on if the block has allowed us to move the cursor on. The block has said, yes, I can be pushed in that direction. Keep going, mate. If the block says, no, I'm not moving, no sir, not for me, you've got to stop, then we may as well stop testing. Because the push isn't going to be allowed. The block has to stop, it can't be moved. So we'll stop testing and not bother doing anything else later on. However, we made this check that if our cursor ends up in null pointer land, then we do allow the move to occur. So we can set our allow push value to true, and because we're only ever moving 1 block at a time, we can also terminate our test. Zoom out a little bit and just have a bit of a recap what's going on here. So we're setting up a cursor that's going to systematically test all of the blocks in the direction that we're pushing. And I've got a flag here to say, well, do all of the blocks along that direction, are they all going to allow me to push them? Because if they are, then we're going to move them all. So I sit in a loop and I test the blocks. I start at the player block because we're treating the player as a block. Can the player move? Yes, it can. Then it goes and tests the neighbor. So let's say we're pushing towards the east, so it tests the eastern neighbor, moves the cursor along one. Can you move in an easterly direction? Yes, I can. So we move the cursor along one, and we keep doing that until either we get a block that says, I can't move, mate, you're going to have to stop, or we get an empty space. We end up with no block, which means, of course, we can move all of these blocks because there's nothing there to stop the last block in the chain being moved. Let me just have a quick catch up with the chat and a mouthful of Coke. So over your head. Meant to be a simple one, this, but I get the feel. The downside is because I can't sort of edit the OneNotes very well. I can't draw them sort of conveniently. So we're doing everything in code, but we're almost done, and that's the nice thing. You'll see how simple, and then we'll start to see how really powerful this technique is. So we've only got the second half of the algorithm to do now, and that is we've now tested can the blocks be moved, and depending on whether they can or not, we've got our bAllowPush value has been set. So we can now do something. If we're allowed to push the blocks, then we need to move the blocks. Zoom in a tad there. Now, at the moment, our block cursor is at the end of the block chain. And I don't mean blockchain like the discussion we were having before the start. So this cursor is technically in the free block at the end of the chain. Here in this null pointer land here, where this 0 is, our cursor is now there. So we're going to work backwards until the cursor is at the original player location. So that's a nice way. We know how far we've got to go. We don't need to do any additional testing for things. We just work backwards now towards the starting location, which is our player. So while our cursor, spell it right would help, wouldn't it? While our v block is not equal to our v player, then we're going to systematically walk backwards and swap the cell that we're on with the cell next door. So we need to know where that cell is next door. So I'm just going to create a temporary little vector, vi2d, and we'll call it vSource, because this is going to be the, we're going to now use the swap function. We need two values. One is going to be the cursor, and one is going to be the neighbor of the cursor in a particular direction. So how do we calculate that source value? Well, we're going to use another little switch block like we did before. So do you know what? I'm going to copy that and paste it in. But we have to be a little bit careful now. For starters, we're operating on vSource. And now we're also working backwards. So we're going to flip these. We're going in the opposite direction to how we were going before. So that will give me a block and a neighbor in the appropriate direction. So let's assume I'm now in this null space here. Let me get a pen. Where's my pen? Pen. There we go. So let's assume now our cursor is here. We've just calculated this cell here. That's our source, because we took the direction that we were pushed in and we went the opposite way. And what we're going to do now is swap these around with each other. And we can do this very, very simply because of the way we've stored the blocks. We're just going to use the standard swap function. vLevel, ID, vSource, doesn't matter what order you call these in because they're just getting swapped, and vLevel, ID, vBlock. And that will do it. That will swap things for us. It'll do it in a reasonably efficient way. It doesn't matter that the contents of our vector are unique pointers or anything like that. Swap will take care of it all for us. Nothing's going to get lost or deleted or confused or duplicated or anything like that. It's just going to handle it for us. And once we've done the swap, we now need to update our cursor position. Well, our update is simply now where the source was. We're just going to move our cursor backwards towards the start. So that's the second half done. If a push was allowed, then we work backwards from wherever the cursor was and move all of the blocks into the neighbouring space. One last thing to do, we need to update our player's coordinate. And that's very simple, because I'm going to take this little switch block again. Just want to make sure I'm in the right set of brackets here if we're pushing. And yes, if we allow the push, depending on the direction of the push, we're now setting our player coordinate legitimately this time. No sort of flipping around, no moving around. So if everything's happened, if we've moved all the blocks, then the player is allowed to move into the cell it was next to, and that's going to be facilitated by this little switch case here. So take the direction of the push. If it's north, we move the player up the screen, south, down the screen, east and west. So. Right. Will any of that work? This is where we've got to have some fingers crossed time. It compiles. That's a good start. So let's run it. So the white square is the player. And as I tap the keys, doesn't matter if I hold them down, you'll see the player moves around. And I can't move into the blue cells. Hissing Stone, thank you very much. Hi Vsauce, Javid here. So what you might notice straight away is, well, hang on, all of that we've just done, we've never explicitly sort of made the player move, except for that very last bit at the end. So it must, in order to have allowed the player to move, it must have allowed the push, even though we're not pushing against any blocks. So the same algorithm is also really implementing this player movement and the collision detection. And you can see it works in all directions. I'll tap really loudly so you can hear when I'm pressing the keys. Now, let's take a single block here. So these blocks can be pushed in all directions. And I can push that until I can't push it any further. I can push it down here. And it's stuck now. I can't pull it, so I can't make it move. Let's try pushing this one into some red. You know, I'm going to go up here so we don't make this prematurely end. I can push all of these red blocks in one go. Which I think is very nice. So, you know, very simple algorithm, very simple framework, and we've got different behaviors going on because the solid blocks can't move, the player block can move, and the red blocks can move in all directions. So we're starting to build up the very fundamentals that we need for a sliding puzzle game. Yes, it probably does need some sound effects. Right, let's add in some different block types, just to prove a point. So let's add in, I think we'll add in horizontal and vertical blocks. So these are blocks that can only be moved in horizontal or vertical directions. So the first one we'll have is block horizontal. And horizontal blocks we'll draw in green. Why not? Now we know that these can only be pushed. If it can only move horizontally, it can only be pushed from the east or from the west. So if from is equal to east or from is equal to west. In that situation, it's true. We can move the block. And what I'm hoping to demonstrate here is by spending the time laying down the sort of framework, it now becomes very trivial to add sort of new and interesting behaviors. So for yellow. For vertical blocks, we'll have yellow tiles. Let's go with yellow. And they, of course, can only be moved from the north or south. There we go. So let's add some into our map, just some test ones to get us going. We'll use minus signs for horizontal. Let's have 3 of them there. And always put 1 in isolation somewhere just so you can try it from other directions. And we'll use the vertical bar sign. That one for vertical tiles. We'll have 1 in isolation down there. Let's go and add these to our loader. So if it's the minus sign, that was a horizontal block. If it's a vertical bar, that's a vertical block. And let's see what happens. Now, I've already forgotten the colours, but I think green was blocks that could only be pushed horizontally. So I'm pressing down here and I can't move them. I can press up and move the red ones out the way. But the green ones don't move. But if I take them on from the side, they can only move horizontally. can't move them vertically. Let's try the single one. And hopefully the yellow one should have the opposite behavior. So yes, I can move that one vertically, but I can't move it horizontally. Yes, very nice. Let's have a quick catch up with some of the chat. Give my voice a chance to recover. I see, now push them all together. We see you can push them all together. Right, so what's the next phase? The next phase is, I think, a more interesting block type. Now this one's, I don't know if they exist in Sokoban, but I thought it'd be quite useful to have blocks that you can only push a certain number of times. So I'm going to create another block type. And we'll call these countdown blocks. And I'm going to actually have a constructor in here to pass in how many times it's allowed to move. And I'll create a little variable somewhere inside here. Int nMoves equals, well, default it to 0. Oh, I spelled that right, hadn't I? And we'll set that value in the constructor. Right, when it draws itself, we should pick a colour. Let's pick cyan for that. And we're also going to draw the number of moves that it's got available. So I'm going to use the drawString function to draw the single digit number of moves. We'll assume it's going to be single digits. And I know my blocks are 16 by 16. I know a single character in the Pixel Game Engine is 8 by 8. So if I want the character to be in the middle of the block, I need to offset it by 4 by 4. So pos times size plus 4 by 4. Just want to make sure I've done my sums right. It'll be embarrassing if the digits are all over the place. Yes, I have. And we want to convert the number of moves to a string type, and I will colour that in black, since we've got a cyan tile, and I'm going to draw the character in black there. There we go. And we'll have these, we'll not have any restrictions on the directions they can be moved. So they can be pushed from all directions. But we need to add this into our level loader now. Now, I'm not going to do this for all possible numbers, but let's assume that excuse me, let's assume that we've got the number 5 to place a block that we can move 5 times. Let's go to our loader. Copy one of those. So when we see the number 5, I'm going to load in our type block countdown and pass into its constructor 5. We could do some clever tricks like detecting was the character a number and using that, but I'm just going to keep it very simple so we can quickly get through all of this video. Let's have a look. Let's play. So here we've got a block with the number 5 on it, and as I push it, well, it's not counting down. That's because we don't really have a way yet of interacting with the block when it moves. So we need to add that in somehow. It's probably quite a useful thing, so a block can update its state when it moves. This means we need to go right back to our base block and add in another base method. And we'll call this one virtual void move. So upon moving, it does something. What it does, who knows? Now all of these don't care very much, but this countdown block does actually care, so we need to override it. And all it's going to do is decrement its move counter. Simple stuff. But we don't want it to be pushed anymore if the move counter is at 0. So we're only going to allow it to move if our moves counter is greater than 0. Now let's try it. Oh, well, hang on. No point in trying yet because we don't call our move function. Where's the best place to call our move function? Well, it's here because the block physically only moves if it's going to get swapped. So I'm going to check, before we move the block, does the block actually exist? Save me typing this out. Let's copy that. So if the block exists, i.e. it's not equal to null pointer, again being dead explicit there, then call the move function on that block. So we're literally, it doesn't matter if you bump into it or try to move it, it's not going to count down. Only on the physical move, when we call swap, do we actually want to call that move function. So now 4, 3 in 2 different directions, 2, 1, 0, and it's stopped dead. We cannot move it, and other blocks can't move it either. One of the things we didn't actually test, were these horizontal? Yes, they were horizontal. So can we actually combine different block types? Yes, we can, you see. Very nice. But we can't push down there. Yes, good. Oh, hey, Tarius. Didn't see you there, man. Good to see you. Is this C-? Very possibly, at the way I'm coding it today. Right, so one thing to add in now is some sort of win condition. When do we know that we've satisfied a criteria of winning? And this is where, well, my approach in this video is going to do it in a really quick, hacky way. If you're going to take this on properly, you'd probably want to do things a bit differently. Usually the objective of these games is to cover a certain tile with a block. It doesn't necessarily matter which block or whatever. So let's put in a winning tile condition, and I'm going to put that in as an @ symbol. So in this case, in order to win, we need to have tiles or blocks on top of all of those @ symbols. There's an argument made here, so there is an argument to be made here that you should store the floor as a separate map to your level. The reason being is, at the moment, I can't specify a tile to already exist on top of that winning condition. Now that does sort of stifle some of the problems that you can create. It means always the goals have to be covered. You might want your puzzle to be more sophisticated and that you've got to take tiles off the winning tiles to actually solve the puzzle. There's something in that. So there's an argument that your floor should be separate, and for other reasons too. What if you wanted regions of floor that could only be pushed in certain directions, or you wanted regions of floor that act like teleporters? You could have an orange and a blue tile, for example, to move things around. So the floor you might want that to be a completely separate structure. You can still interrogate it and set it up the same way. So I'm just doing things for convenience in the same map here. But you know, it's no big stretch, and I'm sure the people watching this will be able to work out, yep, you could have another layer as the floor, and we could draw it separately. You could have all sorts of different things. Depends on what you want to do for the puzzle. I'm just keeping it simple, and I'm going to have my goals as discrete entities in the level. But I don't want them to be blocks, because I don't want them to ever interfere with something moving on top of them. And this adds a unique thing that I need to know. I need to know where my goals are in this level. So I'm going to create another vector, standard vector in this case, and I'm going to store in that vector integer 2D types. I'm going to call it goals, and all I'm going to store in this vector is the physical coordinates of these @ symbols, and we'll calculate those on load. So I should also have done this at the start, shouldn't I? When we're loading a level, we want to clear whatever the existing level is, and we'll want to do the same for our goals. We'll just clear those out, just to be super safe and secure. So now, when I encounter an @ symbol, when I'm loading in, again, not wanting to repeat everything I've just said, you could load this in from a separate map to detect what the floor conditions are. Then I'm going to add to my goals the coordinate of that symbol. Need some curly brackets. There we go. Curly brackets. Found them. But I also do need to add something to my level. I can't allow it to have nothing there. Oh dear, where do they come from? Let's get rid of those. So I also need to push back a null pointer as well, because we're sort of storing things in two separate structures now. Physically, the location is stored in this V level, which is what we're interrogating for drawing things and to keep everything in check. If we didn't add something here, then everything would become out of sequence. and we're also storing the goals as a set of coordinates. And this will allow us now to easily check, does something occupy a particular tile where there is a goal. So we can go and implement this. I'm just using coloured rectangles for the moment, but we will go into writing. Oh, so we will create some sprites for this. Don't worry. Right. So testing for goals. How do we do testing for goals? How many goals have we covered up with tiles? Well, that's pretty easy. Let's just create a variable that counts number of goals, and we'll set that to 0. And then I'm going to iterate through my vector of goals. Need a bracket there. G_v goals. Now, this G is, of course, a vector integer 2D, and a goal is satisfied if there is a block on top of it. So, if in my level, at that location, sorry, ID, at that location, if it's null pointer, nothing exists. That's one of the nice things. But if it's not null pointer, i.e. there is an object there, then increment our goal count. And that's it. That tests for our winning condition. This has one side effect, and what we'll see is that the player actually counts as a block. So we could put in a specific test for that, or you could use it as part of your puzzle dynamic. It's up to you. This, again, is just a very simple block pushing framework. But I was having quite a bit of fun with it when I was prototyping this. So we want to draw the goals to give the player an indication of where they might be, and I'm going to not draw them as part of the tiles. I could check in every single iteration of these nested loops, does a goal exist at this location? I'm not going to do that. The first thing I'm going to do is just iterate through them again. I guess I could have done this up here in the same loop, but hey ho. And I'm just going to draw a circle to say I'm a goal, keeping it dead simple. And the location of that is going to be, right, so G is the physical coordinate in tile space. We need to scale that by the size of our blocks to put it into pixel space. But we want to draw this circle in the middle of a block, so I want to take the block size and divide it by 2, so that gives us our position. The block size is going to be equivalent to the radius. Now, if we were working with rectangular blocks, we'd have all sorts of fun and games here, but fortunately I know that they're square, so I'm just going to take the width of a block and divide that by 2. And that will give us a full block circle. That's probably too big, so I'm just going to shrink that down a little bit. So doesn't occupy the entire square, it's just a nice circle within the square. And we'll colour that yellow. I'm a goal. And I think it's useful to inform the player how they're getting on, because when we've covered up the goals, you won't be able to see them. Again, graphical decisions you can make and display in different ways. I'm just going to display boring text at the top of the screen. So I'm going to call drawString, and we'll start at 4 by 4, which will be in the middle of the top left tile. And I'll call that goals. And do a bit of string mangling here. Standard to string. That's not going to work. That'll be better. So how many goals have we got so far? Well, we know that that's our goal count variable. And I want to do that out of, there we go, standard to string. How do we know how many goals we've got? Well, conveniently, we stored them in a vector. So let's just look at the size of the vector. And we'll colour that white. Anything I've missed? Let's have a think. We'll find out. So those are 3 goals, the 3 circles there. And is it possible for me to actually put any blocks on them? Let's have a look. There we go. So we've covered up 1 and our goals has increased. Now the player still counts as a block, don't forget, so you can see that goes up and down as I move along. Perfect. And at that point, once we know we've got 3 out of 3 goals, we could move on to the next level. It's one thing to do. often it's the case that you mess things up when you're doing these games, so we need a reset function to be able to reset the level. How you score these things, it could be that you count the number of moves that the player is doing, or you can count the time. There's various different ways. Again, this video is just about the mechanics of multiple blocks pushing around. And I'll also briefly mention about not pushing multiple blocks if you want it to just be one block at a time. But for now, we want to reset, don't we? So let's make the R key reset. So I'll be sensitive to the R key being pressed, and you might think, well, resetting is actually quite a bit of effort. Well, it isn't, because we used unique pointers. So I can just load level, load whatever level. You could say I'm just passing in 0 and it doesn't even do anything, but you could pass in the particular level count that you're on. The first thing the load level does is clear the two vectors and reconstructs everything. And by clearing the level vector, we're automatically erasing all of these objects that we've created. So very nice, not going to leak. So as I move things around, let's make a mess. Push these here, and let's move our counter block. There we go. I press R, everything gets reset. We've not jumped up a huge amount of memory, so that's good. Everything's in a nice place. So I think there's one thing left to talk about, and then we'll actually change it to sprites and make it look pretty. How long have we been going anyway? Not too bad. We have run over a little bit, and we always do when it's live. It's just the number of questions that get asked. Right, one thing to talk about. So what if we did want it so you could only move one block at a time? Well, the easiest way, and I've not done it, and I'm not going to hack it live, totally live, is you could just keep a count of how many times you've iterated through this pushing loop. And I was thinking about how you could augment this even further. You could have each block has a mass. So let's say you could push up to a total number of 5 units, whatever it is, and each of the different block types have different weights. How do you make that sort of dynamic? Well, you just add in another base function which returns the mass, and as you're going along, as you're moving the cursor along, you accumulate these masses, and as soon as you hit the threshold where you can't push any further, you return the test is false. It can't move. You don't allow the push. So that's also another dynamic we could add into this game. I think quite a useful one as well. It's in a way it's similar to the limited number of moves you could push a block around for, but it works from a slightly different dimension, as it were. So lots of different things. So you'll see if I just zoom out here, including the level, all we've done is define different block types. These are those really small bits here. They've defined different block types. There's basically no code at all. Right? It's how do we interpret the level and create the objects, and of course that could all be streamlined if white space is one of those things you don't like. And all we've got really is this very simple loop where we check the blocks being pushed outwards. If the push is allowed, we allow them to move, and we move them all one block to the right. And that's it. Even drawing it, we did the drawing routine at the start. We've never had to touch it again. But let's make it a little bit more interesting. Oh, Gareth! Hey, I didn't see you there, Gareth. Time regeneration of pushes and in-app purchases. Yeah, I think we will make the PegX, the Pixel Game Engine extension for in-app purchases. That will be coming very soon. What was I going to do? Completely distracted. Gareth totally knocked me off the rails there. Lip your neck. Where am I up to? I was up to going to start doing some graphics, I think, because I think what we do is we know our blocks are 16 by 16 pixels, but let's make them a little bit more interesting. I have here, I call this Asprite, but I think it's Asprite is how it should be pronounced, and I think this would be an opportunity for well, now is probably a good time to ask some questions whilst I'm drawing this, because the video is almost finished from a code perspective, so if anybody has got any interesting questions, then shout them out. But I'm going to get these in a particular order. So I want a solid block. This is where I know there's a couple of guys in the chat that use this software backwards, and they'll be looking at me going, oh, how come it's so slow? What are you doing? And for blue, I'm going to put in a little bit of highlighting on these things. Let's put a shadow at the bottom. So this is the stuff you don't normally see in videos when I'm making it, but I want it to be complete this time round. Let's highlight those like that and click the corners away. can make those alpha. There we go. Have you done any videos on smart pointers? Yes. Yeah, I did actually. My video on what are pointers actually covers smart pointers as well as regular raw pointers. Can you show us your elbow? There you go. Don't say I don't do anything for this community. Can you limit yourself to palette? I knew somebody would ask that. No, I can't. I'm not going to. I'm doing these things far too live to do that. So I'm going to have a... So my blue block is going to be solid. Let's put in a red one. I did ask yesterday. There's a guy, Rui here, is one of the moderators. May or may not be here at the moment. We know him as Tutus on the Discord. He can use this software like nobody else. He's absolutely brilliant at using it. And I was asking him what are all the key codes to do things a bit faster for the video. Now, because this is going to be my simple block, I want some sort of indicator on it that I can move it around. I think if I hold down Alt, there we go. I'm going to use the plus on it that sort of indicates I can move this in any direction. There we go. Let's move on to the next one. We'll have horizontal and vertical blocks, and we'll colour those the same. We'll just put in, oh dear, that was a mistake, wasn't it? I can't see where the thing lines up. Let's doing art live. Never do art live. Lesson, note to self. This is horrible. I think we need a bit brighter for that one. There we go. Let's get rid of the corners again. And we'll just cut and paste that. Why would I use this? Well, one, it was bought for me by a member of the community, which I'm very grateful for. But also, it's actually very good at doing this. It's very good at pixel artwork. And given that I work predominantly with the Pixel game engine, it makes some sense in my mind that it's the right tool to use. So we want one of these to represent vertical movement, and we'll have one that represents horizontal only movement. Oh, I've got an errant green pixel there. Don't know what that's about. Let's get rid of you. What type of block have we not covered? We've got movers. We've got the countdown block. We've not covered you yet, have we? Countdown block. Let's go for green. Let's pick a darker green. Lighter green. So I was hoping that there was going to be some sort of automatic shading tool built into this, but there isn't. Well, at least I've not found one. And these are going to be countdowns, so we're actually going to draw the number on there. Have I missed a block type out? Solid blocks, we've got the player, that's going to stay as a rectangle. Got the move everywhere, horizontal, vertical, countdown style. Have I missed a block? Goals. So I'm going to keep the goals as little circles. Will this tutorial be available after the stream ends? Yes, it'll just be a regular video. I'm not going to, it'll just be this stream. Let me save those. So save as. Although the sprites from, oh, when was that? That was the 100k, wasn't it? Blocks.png. Okay. We'll run with that and see how well we go. So last bit of code is just to add in the graphics now and make it look a little bit more presentable. And to do this, we're going to use a new type. So those of you that are dead familiar with the Pixel game engine might not have seen this. It's snuck in without very much fanfare. We're going to use a type called a renderable. And I'm going to create another unique pointer. See, I'm getting into the habit of using smart pointers for things. On the whole, some of you will like that, some of you won't, but you know, we'll see how it goes. So what I'm going to create is a renderable for my graphics. Now, renderable simultaneously loads a sprite and creates a decal, which is certainly a PGE2 thing. We've not used decals today, and I've no intention of using it just yet. And we'll call that tile. So that's going to load up that image that we've just created. And I'll go down to my onUserCreate function and actually load. That's a GFX tiles.load. And I know that the function is gfx/ what did we just call that PNG? Blocks.png. Oh, I hope I've got that right. So we then load our graphics, and now we want to be able to pass the graphics into all of these objects. Now there's lots of inelegant ways using static pointers and that sort of thing. I'm just going to simply pass it in by modifying all of the draw self functions to take in a reference. Oh, excuse me, a reference to this particular renderable. Const OLC renderable. And we'll call it skin. And the idea being is that you can create your own tile sheet and you can just load that tile sheet once and reuse it everywhere. And if you wanted to have a completely different look and feel on a different level, you don't have to necessarily change the underlying graphics that it's all tapping into. You just pass in that particular single sheet of graphics. Now, of course, that's going to have upset all of my subsequent overrides. Fortunately, Visual Studio tells me where they are, and so it's just a cut and paste job to sort them all out. There we go. And when we actually render the tiles down here in the draw self, I need to pass in my GFX tiles. That's what I call it, GFX tiles. Now, the objects themselves aren't just going to miraculously start drawing the sprite now. We need to change these fill rects into the equivalent draw whatever for that particular tile. This is where I'm going to get everything backwards and upside down. Let's start with solid block. So we're no longer just going to fill the rect, we're going to call PG draw partial sprite, which takes out, what it allows us to do is we're going to specify the source location within this larger sprite, and it'll chop that out and draw that for us. So draw partial sprite, and the arguments are pretty similar actually. Pos times size. The actual sprite is going to be our skin, and we're going to take the sprite component of the renderable. So as I've just mentioned, a renderable combines decals and sprites, and it is going to be sort of the recommended way now to access sort of image data going forward in the Pixel game engine. There's a variety of reasons why that's the case, but if you prefer the old way, that's totally acceptable too. And I'm going to do something odd because I know that my solid block is this first one along. So its coordinate is 0, 0, but just to make these things a little bit easier to change later on if I need to, I'm going to create a null vector there times size. That's giving us our top left position, 0, 0 times size. And we also need to pass in the size of the bitmap or PNG that we want to chop out, which again is just size. So it's all very simple stuff. And I can copy and paste that line for the different block types. So block player, I'm just going to leave as a white rectangle. Block simple, and get rid of the colouring in bit. But let's go and have a look. Where did we say? So that's now 1 over. That's our first block. Oh, flipping heck, don't look at my desktop. It's a terrible mess, isn't it? So now we're going to look at, yes, block simple, which is 1 over. And now we will go over to horizontal, which is, horizontal is 0, 1, 2, 3 over. 3 over. Oh, got some, hey, look, you know, I'm a busy guy, right? Desktop's a busy place. And so vertical was, I've already lost count now, vertical was 0, 1, 2, 2 over. I'll put that there to a 2. Countdown block. We still want to do the drawstring bit, but we're going to do it a different colour. That was, oh, I really lost count. 0, 1, 2, 3, 4. That's 4 over. 4, and I don't think there's any more block types left. So, providing I got the file name correct, which chances are I'm not having much luck today, am I? Ah, aha, ta-da, there we go. We've now got graphics, very simple graphics, and we can now make sense of what the blocks are telling us. So this one can be pushed in all directions. These can be pushed, but they get stopped by those blocks there that can only move horizontally. I'm going to be careful here, else I won't be able to move those blocks vertically. There we go. We can move those vertically. They can be moved, and our countdown block, 5, 4, 3, 2, 1, 0, can't move any more. Blocks can be stacked like this. That's quite nice actually. I like the block stacking. Let's try just mixing those up a bit. So yeah, it's quite happy with that. Job done, I think. The very basic mechanics of a sliding block puzzle game. Now, should I... No, I don't think I will. I think we've gone on long enough since this has to be an uploaded video. Oh, well, thank you there, Inexcitus. Thank you very much. So that's not too bad, right? In an hour and a half, you know, we've sort of thrown together the very basics. We've not created actually any levels. And I'm going to leave that as a bit of a challenge for you guys. So a bit later on today, I'll upload the source code. It would be interesting to see what people can do with this. And if you're on the Discord server, do actually sort of post screenshots or post the levels. One of the things we could do is establish a common language for what these level formats are and start exchanging them as puzzles for people to solve and pass around. I'll bring that back on the screen so we can stir it. Oh, I can press R and everything resets. So yes, a puzzle game video without actually creating any puzzles there. Now, I've got one last thing to mention. I did mention at the start. I don't know how many viewers we've got because I cover those numbers up, but the Code Jam is officially going to start in a month, right? I know that seems like ages away, but it's to give people enough time. I know a lot of people want to actually book a little bit of time off work or something like that to spend a couple of days on it. Certainly that's what I'm going to do. It starts in a month's time. It's a Code Jam. I'm not going to reveal what the theme is, of course, until the start. And it's... because it's a code jam, it doesn't have to be games, it can be applications, it can be all sorts of interesting things. It's usually a very popular jam each year. It's a lot of fun. It's only 1 week long, but it starts in about a month. If you're interested, do join up. The only thing to win is internet points, but usually most of the sensible entries get featured in a video later on too. So there is that, particularly the winning video. So that is all from me. I think there we go. We've got a very simple puzzle game, which leads me to say the usual stuff. What do I normally say at the end of a video? If you've enjoyed this video, please think of... Oh no, I've said it wrong now. Start again. If you've enjoyed this video, please give me a big thumbs up. Have a think about subscribing. Come and have a chat on the Discord server. And I'll see you next time. Take care.